Dear students, Assalamu alaikum. Today we are going to discuss the signs of trigonometric functions. Now for this, let me consider a circle with center at the origin in a plane whose radius equals to 1 unit. That is, this is the circle. Here O is the origin of this circle, and let P of AB be the only point on the coordinate on this circle. That is, here P of AB is the point on this. Now if we consider the image of this point P of AB through the x-axis, then clearly the point that is its image lies or is this point P dash. So the coordinates of this point are clearly a minus b, because here x remains same. The only one thing changes, that is the sign of the y coordinate, that is b. Now let the angle between this OX and the OP, that is angle X OP, is X quadrant. Now we are measuring this in anti-clockwise direction, that is in positive direction, that is X is here positive. Similarly, the angle between P dash OX is minus X, because P dash is simply an image of P of AB. If XOP is X radian, clearly x of P dash equals to minus x radian, because here we are measuring this in clockwise direction. Now join this P and P dash such that this M is the point of intersection between x axis and this P dash. Now then clearly OM equals to A, because this equals to this, and PM equals to B for this point P of AB, for this point P of AB, because here it is OM and it is PM, which is PM is here y coordinate, which implies that y coordinate is B and x coordinate OM equals to simply x, this A. But we know that this OM is simply polar coordinate. In terms of polar coordinate, it equals to cos of x, because x is here for this point, x is the angle, so it is cos of x equals to A and sine of x equals to B. Now name it equation first. Similarly for this point P dash A minus B, OM equals to A and P dash M equals to minus B, because P dash M is simply the y coordinate, length of y coordinate, which is minus b. Name it second. Here A equals to, from first and second, A equals to A, so the cos of x equals to minus cos of x, because for P dash A minus B, or for this image point, the angle is minus x, so the x coordinate becomes cos of minus omega, this cos of minus x, hence cos of minus x equals to cos of x, and here sine of minus x equals to minus b, but in from first b equals to sine x, so sine of minus x is minus sine x. This means that for any x or for any angle, cos of minus x is always cos x, and sine of minus x is minus sine of x. Similarly, we can find the sines for tan, cosec, sec, and cot in term, because tan, all the remaining 4 trigonometric functions are defined or x or equals to the ratio of these 2 trigonometric functions, like tan of minus x is minus tan, cot of minus x is minus cot, cosec of sec of minus x is simply sec x, and cosec of minus x is simply minus cosec x. Now if we consider point AB, like here in this if we consider here point of P of AB as a point in the first quadrant, here this plan, that's x axis and y axis, divides the circle into 4 equal parts, that is quadrants, into 4 quadrants. Now in first quadrant, if we consider point in the first quadrant, the angle is here, the acute angle, that is the measure is from 0 to 90, and for this point both a as well as b are positive, because x and y coordinates are always positive in this quadrant. So when x and y are quadrant, this is positive, this means that this cos a is here, cos of x, because we are considering the circle with radius equals to 1 unit, so it is simply cos x equals to a. But if we consider the circle with radius equals to r, then we have to consider here a equals to r cos x, where r is the radius. Here r is 1, that is why we have simply cos x equals to a. Similarly, sin x equals to b. This is always for any general point. But a and b both are positive in the first quadrant, and x is acute. So this means that sin x and cos x, they are positive, or they are non-negative. Non-negative means they will never be negative. They may be 0, or the value may be positive. This means that sin x and cos x, when x is acute, means in first quadrant, the value of these functions is always greater or equals to 0. When sin x and cos x are greater or equals to 0, then clearly the remaining 4 are always greater or equals to 0, means they are non-negative in the first quadrant. Non-negative means the value may be 0 or positive, but the value may never be equals to 0. So this is for the acute angle. Now if we consider the obtuse means when the angle is between 90 and the 180. So this means that in the second quadrant. Now in second quadrant, here if we consider point P of AB, here A is negative. A is, because x is negative in this, but y is positive. So when A is negative, A is defined as cos x is negative and sin x is positive. So this means that in second, cos is negative but sin is positive. So from these two we can find for tan, it is tan of sin by cos, because tan equals to sin by cos. Now sin is positive, cos is negative, because x is obtuse angle, sorry. So the ratio of positive and negative is always negative, so it is negative. Similarly for cosec, 1 upon sin is positive, hence cosec is also positive in second quadrant. And cot is cos upon sin, the ratio of negative and positive is always negative, so it is negative. And sec equals to 1 by cos is negative, hence implies sec is. So this means that in second quadrant only sin and cosec are the positive, but remaining 4 are negative. In first, all are positive. In second, sin and cosec are positive. Now if we consider third quadrant, in third quadrant the angle is here. If we consider a point like this, here angle is, the measure of the angle is this. So this means that here the measure of angle is greater than 180 and less than 270. Now in this quadrant, if we consider x is negative, because here we have to consider this portion, and this y is negative. So this means that both a as well as b, the coordinates are negative for any point in this quadrant, in the quadrant third. So when both are negative, implies sin x is negative and cos x is negative. Negative means less or equals to 0, non-positive. Now tan equals to sin upon cos. Sin is negative, cos is negative, which implies that negative is always positive, because ratio of two negatives is always positive number. So this means that tan is positive in third quadrant. When tan is positive, implies that cot is positive, because cot equals to cos upon sin. While as the remaining two, sec and cosec, they are negative, because sec is 1 by cos and cosec is 1 by sin. When cos is negative, 1 by cos is negative. When sin is negative, 1 upon sin is negative. So this means that in the quadrant 4. In third quadrant, only tan and cot are the negative positives, while as the remaining 4 are negative in this quadrant. Similarly, if we consider the fourth quadrant, in fourth quadrant y is positive, means a is positive, so means b is positive, and a x is positive here, while as y is negative, that is a is positive, b is negative. So this means that in this cos is positive, sin is negative. So from these two you can find the remaining, and in this we have only two, which is sec and cosec. Sec and cos, these are the two functions which are positive in this, but the remaining four are negatives. Here the measure of this, or the measure of the angle for the points in this quadrant is always greater than 270 up to 360. 270 up to 360. So this means that in this way we complete signs of trigonometric functions. So usually for acute angles all are positive. In second quadrant the sine and cosec are positive. In third, tan and cot are positive, and in fourth the cos and sec are positive. So in this way we complete this topic. Inshallah, in tomorrow's lecture we will discuss the trigonometric function, their domains and the graphs. So thank you.